Thank you for joining us today and welcome to this webinar, Utility Protocols and IoT Edge Gateways. I'm pleased to introduce our speaker, Mr. Nirmal Talail. Nirmal is an AVP responsible for product management of Calcitec's sync, communication, and automation products. He has extensive expertise in product management and energy solutions and working with power customers. The presentation will approximately be about 45 minutes, and questions will be answered at the end. Attendees are invited to submit questions to Nirmal using the chat box on your screen. Should we not have time to address all questions, Nirmal will follow up with you individually after the webinar. So without any further ado, I'd like to turn it over to Mr. Nirmal. Nirmal, over to you.
Welcome everyone. So today we'll be discussing upon the why utilities need to adopt edge-based technologies or edge-based solutions in the current infrastructure, and what would be benefits which it would bring to the utilities. So first we'll have a quick look at what are the new challenges utilities are facing right now due to the various grid modernization initiatives from various directions. We all know traditional electrical power grid was having a unidirectional power flow, that is mainly there's a large central generation units which can generate electricity. It's been transmitted to consumers through a transmission and distribution system. But recently there's a huge change in the energy business, mainly due to driving factors from various angles, including the business economics, technological innovations, regulatory changes, and public policies. For example, the public policies, you can see that there has been a huge uplift of the environmental policies, due to which there's a shift from the traditional coal and nuclear based generation to a gas combined cycle units. Another push is on the net zero metering on the distribution of the consumer side, where consumers are flexible to generate their own power and push to the grid. So all these changes, all these drivers has paved way for a large distribution generation in the network. So the consumers are becoming prosumers, which they look at the electricity grid as a mainly to balance the generation and the demand. And they also look at the grid as a backup supplier in case of emergencies. So due to all the distributed generation, energy resources or generation units coming out in the field, the power flow has become two-way or bidirectional instead of the traditional unidirectional power flow. So this change has bring us a huge complication in the electricity grid and the distribution operations as well, managing system as well. Another driving factor is the introduction of the electrical transportations. Mainly, again, this has been pulled in because of the environmental policies which are actually put across by different governments. Due to the introduction of the electricity transportation, there has been an unpredictable demand of the electricity in the distribution network. And on the transmission side, if we can look at the HVDC and FSDT as become the very common across all the transmission network, mainly to have better control on the frequencies and the voltage on the network. So all these changes has bring in communication in the electrical grid, transmission, as well as distribution of automation, which again requires an integrated T&D planning uh, requirement. So, in order to minimize the effect of grid modernization, uh, utilities or the asset owners has to digitize the grid as much as possible to have better control of the system and also to enable normal operations as before. So this digitization helps in using the system to have better adaptive protection and control system, and also have a granular visibility of the network, and consumers can consumers have need to have both participate in the wholesale electricity market, which brings the demand for security as well as privacy on consumer angle. There should be an access to the actionable data and comprehensive modeling and simulation of the data is also required as part of the digitization of the gate. So all these changes demands for the data collections from traditional devices as well as from the latest IoT sensors and IoT platforms as well. And we need to have process the data from the field as well as from the IoT platforms, either on real-time basis or on the historical data as well. So the latest technology development have helped us in achieving these goals. Like, for example, the IoT technologies which has been which was introduced recently in the market, as well as the analytic techniques like the machine learning and artificial intelligence, which we can deploy at the field, also helped users to collect the data as well as do the processing of the data at the field level itself. So the advantage of processing the data at the field level is to have a rapid decision making from the field, which would be beneficial for most of the utilities. So the edge connectivity will looks similar to this network, where you can see over here there's the edge gateways, which is sitting in the field. These edge gateways will be connected with legacy devices like production relays or controllers, or maybe a metering equipments like energy meter or power meter, which will be having direct CTPT inputs. And all these devices are capable of communicating on various legacy protocols or standard protocols. And there's also new types of IoT sensors coming out in the field, like source sensors, for example, which we can collect data from the sensors and send it out to the edge gateways on various IoT protocols. And it includes the latest technology, environmental sensors, like weather sensors can also be plugged in at the gateway level itself for processing data from the field. So all the data collected from the field can be processed and can be put across for analytic engine, and the processed data as well as raw data can be sent it out to the data center through a public or private backhaul on a secure channel. So all this data has to be sent to traditional OT systems like SCADA or DMS or EMS systems, as well as storage systems, and these data also has to be sent it out to a latest IoT platform based system as well for advanced analytics or system-wide analytics applications. And there's also a need for having an identity and access management system, mainly to enable the security or role-based access control to devices as well as data out there in the field. So these are the functions or features of edge gateways, which is required mandatory for all these edge gateway softwares or edge gateway hardware. So all the edge gateway softwares are expected to collect data from uh, different equipments. For example, the legacy protection and measurement devices on protocol which is supported by that devices, as well as it also needs to collect data from latest technology sensors to enable with IoT. So it is critical to have support for the standard-based protocol as well as legacy proprietary protocols needs to be enabled in the edge gateways in order to achieve this function. Uh, all the collected data will be sent out to the data processing engine. The data processing engine should be capable of having a user configurable data processing capabilities. But such as it could be a 601 based engine, or it could be an advanced analytics engine based upon the ML, that is machine language as well as artificial intelligence integration. So these are the bare minimal requirements for an edge gateway gateway as such. And we can also use the edge gateway also as a protocol conversion in order to send data to the traditional OT systems. So all the data collected from the IoT sensors can be converted into standard protocols like 6150 or 6070, and should be sent it out to a SCADA system as well. So that is also a critical requirement for the utilities. And the edge gateway should also have the inbuilt security to ensure that data is not being lost or not being changed while at the rest or in the motion. So there should be enough encryption as well as authentication mechanisms to be built in all the protocols, as well as there should be a role-based access control mechanism to assess the configuration and monitoring of the data from the edge devices. And talking about the manageability, since these edge devices are deployed at the field or at the remote locations, there should be an option to have a remote configuration and settings from a central location, from a central platform. And it should also be able to update the firmware as well as the OS patches remotely. Basically, mainly for enhance the features or functions of the edge device, or it could be a security patch which needs to be uh, pulled into the device. So edge, edge gateway software should also be flexible enough so that it should be able to deploy it on your hardware or any of the hardware. Standard hardwares are available in the market with any operating system, and it should also have the capability to connect with multiple clouds out there in the market. And edge device also should be able to send data to the peer devices, especially the use cases like self-healing grid, where data from edge devices needs to be processed by other edge devices to make a decision on whether grid network should be isolated or it should be connected back to the network. And obviously, the edge devices, as you can see, that is located in the field, it can be deployed in the field. It is not necessary that it should only be deployed at the field. It can be deployed at any layers in the network. So the scalability is also a critical factor for an edge software application, where it could be in some locations could be a few tens of devices or hundreds of devices. On some locations that we should be able to connect with hundreds and thousands of devices using a single hardware. So the scalability is also a critical function or features to be available in the edge gateway. Next, we can see what are the layers, software layers, which is critical for an edge software. As you can see that the software has been mainly classified into two layers. On top, you can have the add-on applications, which users should be able to program and run it on the edge devices. It could be any applications which is required as per the requirement. Below the application, there should be an edge gateway middleware. So this is the critical component of the edge gateway software. But there should be software should be able to have three main layers. One is that data exchange layer, and on top of that data exchange layer, there should be a data management layer, and out that there should be a monitoring layer. On the data exchange layer, as we discussed, it should be able to exchange or communicate with various field devices out there. It could be a standard-based devices like IEC 650 or DNP3 or IEC 60870 protocol devices. And it should also be supported to communicate with the legacy field devices like a Modbus or BACnet or Ethernet IP devices as well. And it should also have support for the device management protocols, M2M and IoT platform communication capability should also be available in the data exchange layer. Basically, the IoT platform connectivity option enables edge devices to connect with any of the IoT platforms out there in the market, so that they can use the current infrastructure itself and collect the data from the field. And all applications which is already been deployed and in some of the IoT platforms, they can still use that by just using the edge device at the front end. And it also has support for supervisory system protocols like protocols which is required to send it to traditional OT systems or SCADA systems. For example, the DNP3 or 101, 104 protocols has to be supported. We will have a detailed look at what are the protocols which is required in the edge software in the coming slide. Okay. So on top of the data exchange layer, there should be a data management layer where it should be a model-free data. All the data should be stored in the internal database of this software. This database should be able to capable of handling the real-time data with a minimal latency, and as well as it should also be able to handle the commands and settings from the central location or from the analytics applications. And there should be a quality of service or QoS mechanism to flag that if there is some critical events or some commands needs to be sent out to the field. Those has to be handled on priority. So, so that will also be part of the data management layer. It could be a rule engine like a maybe as I mentioned, it could be IEC 61131 engine. User can configure any logic. It could be a math logic or maybe a logic function which can be used upon the data collected from the field, and those rule engine can do some processing of the data and store it internally in the database. It could basically maybe a scaling pattern application, or it could be a multiplication pattern, or maybe converting into power into energy, something like that. And there should be a scheduler or timer which will basically responsible for collecting data or maybe sending out data to field devices on a specific time or in a specific interval. And there should be a data storage or archiving function of the data. The edge devices will normally have a limited memory, So all the data which has been collected from the from field has to be archived on a periodic basis. On top of the data management layer, there should be a monitoring layer, uh, which again should be a user configurable model. It could be data could be modeled on top of a geo map that is a location-based uh, mapping of the data. It could maybe superimpose the data on top of a geographical map, or it could be electrical network map, for example, the single line diagram from the of the electrical grid. Uh, all the data from the field can be mapped and superimposed on a electrical network. There should also be support for the device models. So various devices support various functions like maybe for example protections functions. It could be overcurrent protection or under voltage protection. So depending on the functions of each devices and device models, there should be mapping of data from these devices to the device-specific data modeling option. It could be also domain-specific model, for example, like mapping a data flat structure map data from the field into a asset model, for example, transformer model based upon the scene. Should be able to map, and this model can be exposed out to an analytical application for advanced calculation or analysis. And they should also be capable of mapping the data to a communication topology or the network topology of the system. All the layers should also have the interface layers or APIs to exchange data from any third-party applications, and also there should be common security security layer, which will capable of it should be responsible for the data security, encryption, authentication, as well as the role-based access control of the system. Okay, so on top of the edge gateway middleware, user can build any applications which will basically collect data from edge gateway middleware using the APIs exposed by the middleware, and you should be able to build an application like a machine learning analytics or a pattern matching applications. For example, voltage profile matching in case of a specific fault happening. If you want to compare that voltage profile with a predefined set of patterns, that should be able to match using the pattern matching applications. It could be a distributed field applications. For example, self-healing grid applications where you want to make the decision from the field itself, depending upon the current network topologies. Which requires a peer-to-peer data transfer from the one edge devices to another edge devices. And we could you can also build an asset management applications where you can do a conditional monitoring on the field and do the predictive maintenance of the field assets from the data collected from the various sensors and the equipments out in the field. And again, the add-on application could be a local monitoring application where you can build your own web-based apps to show or present the data collected from the field on a on your web page. It could be with a single line diagram or with a geolocation map. Or there could be an anomaly detection application which can be built on top of the edge gateway middleware. So these are few examples. So you can build your own huge set of applications depending upon the requirement for the utilities. So that will be a flexibility if you have the edge-based solutions. We talk about the Calcitech software stack. SYNCConnect is the software pack which is used or responsible for the data exchange layer as well as data management layer. So SYNCConnect can collect data from various assets out there in the field on various protocols. We will see the protocol list in the coming slide. And SYNCConnect can also responsible to store the data as well as exchange data with traditional OT systems like SCADA, DMS system, as well as with uh, latest IoT platforms as well. On top of the SYNCConnect data exchange layer, there's a Calypso plane, which is a data modeling and data management layer where you can model data as required. Calypso plane uses OPC UA to model data using the OPC modeler. So that is also purely user configurable modeling tool. And on top of these two software pack, end user or maybe system integrator can build any third party, any applications like used for the energy or power, or maybe for the oil and gas application also. So SYNCConnect is not, Calypso plane is not restricting users to use only for the utility applications. It could be also for the other industries as well. So, so these are the connectivity interfaces which is supported in the SYNCConnect. Um, so as we discussed in the previous slides, SYNCConnect should be software stack should be able to connect with legacy devices, protection devices on standard protocols like IC 61950 on MMS or Goose or sample values. So you should have the client capability to collect data from these field devices, as well as it also has capacity to collect data from the DNP3 devices like RTUs, etc. Or RTUs can be either IC 608, 101, 104, depending upon the geography or utilities, or the equipments. You can select which are the protocols which needs to be enabled in the device. It could be also be IC 103 based protection relay, um, which is also communicable on the communicated with the SYNCConnect on a serial bus. SYNCConnect can also be enabled with IEEE 7.118 at the facial data to connect your facial measurement units out there in the field, and it will also stream the data to a central facial data concentrator, or it could also be used to convert data into legacy protocols uh, to send it out to a SCADA system as well. And it also supports the 62056, that is the DLMS code for counting your energy meter data as well. And 61400 is a sub-variant of a 650 standard for the wind industry. Talking about the legacy device communication capability, it supports the Modbus and CC12 LAN and BACnet protocol to connect with your standard legacy devices, which is already deployed out there in the field. And it also has capability to connect with proprietary protocols from major OEMs in the utility industries, from example the ABB or Gaten or the Siemens, Cell, ZIV, etc. In addition to all the data collection capability, there's also protocol drivers or adapters to do the associated functions. For example, the SNMP, which has got the SNMP, SYNCConnect has the SNMP agent as well as SNMP manager, which can connect with your networking equipments like switches or routers, collect the data from these devices and send it out to the SCADA system as well as with the IoT platform. And it also has the inbuilt NTP or SNTP or PTP support, depending upon the hardware capability. It can be used to synchronize time of the edge devices, and also edge devices can also synchronize time of your end devices using these protocols. To have an extension of the edge capabilities, if in case you only have an application which is already deployed on standard IoT platforms like Azure, Amazon, or G Cloud. If there's a connectivity option provided along with the SYNCConnect, where you can push all the data collected from these devices to your application deployed in Azure or Amazon or Google Cloud. If there's any your own proprietary cloud platforms, it could also be sent it out on MQTT or PCUA as well. And in order to send the all the legacy device data as well as the standard device data to a SCADA system out there, when the OT network, it also has server capacity for IEC 690, DNP3, 60870.1.0.1.0 protocol as well. It also has the LMS COSM server to send or serve data to your AMR header. In case you want to collect data from various assets and send it to an AMR system for advanced analytics system applications. It also has the ICCP, that is Inter Control Center Protocol, to send data to your main control center SCADA system as well. In case SCADA have only support for ICCP, edge device also have capacity to send data on ICCP. So these are the applications we discussed as we were seeing in the grid modernization initiatives. There has been modernization happening in the generation side, transmission side, distribution side. So edge-based solution is being commonly deployed. It will be a better tool to be used for all different applications, different application areas easy. So this helps utility to have integrated T&D planning, as well as utility business has also been converted from the traditional energy delivery operations to a transform into a services of business, where they also, utilities are also interested in installing installing the distributed energy resources, and also they are also changing the business model to have like aggregating the consumers to enter into a wholesale energy market as well. So these are the advantages, or these are the application areas where edge gateways can be used in. So with this slide, we conclude our presentation or webinar on the utility protocols for the edge gateways, what are the necessaries and what are the application areas and how it is used. In case if you have any questions, please type it on your chat box. So yeah, one of the questions which I got is how to add or how the protocol is being enabled in the software. So to answer that question, so there are various options. SYNCConnect comes with a default set of protocols which are licensable. You can license it using the product license which is available from our platform, Kalki IO platform. And as per your requirement, you can enable this protocol. In case if there are some protocols which needs to be developed or which needs to be added on request basis, it requires a separate set of update from our side, from Kalki. and you can update that patch, update the software as a patch into a system, and you can use it with the add-on application or add-on protocols. So question I have is Kalki.io. What is Kalki.io and what is used? Kalki.io is our again IoT platform Kalki Tech, and you can use it um, as a device management system. It can be used to um, mm, manage, like you can download the configuration or update the configuration remotely from a central location. It can also be used to update the firmware and patches from the remote location. So all the remote management can be done from Kalki.io, as well as it also has capacity to work as an identity and access management system, where you can set user roles and responsibilities in the Kalki.io, and that can be used to do any operations or engineering on the system. So it uses PKI for X509 based certificate based infrastructure to manage the role-based access control system. So Calcaio can also be used to build application, your own application on top of the platform. You can, if you have to build an system-wide application. So Calcaio is as an IoT platform. You can build your application on top of the Calcaio.io as well. Uh, yeah, another question I have is, can you elaborate more on the distributed data processing? So regarding distributed data processing, one of the example which I just put across is a self-healing grid, where you have got edge devices deployed in the distributed grid, and edge devices can collect data from your various locations in the distributed network, including the switch position as fault passage indications and other protection functionalities as well as can be collected collected from the field. And in order to have an application like Plisser, that fault location identification and restoration, at the moment that the fault has happened, you can use the edge data processing, and which is being carried out by edge devices by peer-to-peer communication. And by sending data from one edge devices to other edge devices, all the devices get the status of the positions and the voltage levels at the different locations in the grid. So these data helps edge devices to do distributed data collection as well as processing from the field, and do the Plisser uh, location isolation as well as the system restoration from the field level itself, rather than doing everything in the central location. Okay.
So if there are no further questions, I think thank you all for joining us today. Please check out our other upcoming webinars we will be hosting. We also will make the past available webinars for you to view. Thank you so much for joining today and have a good day. Thank you, all. Thank you.